Okay, good evening. Last day, we have discussed about the system development life cycle and the steps of system development life cycle. So we discuss so basically we discuss why the system development life cycle is needed, because information is one of the most important, and so that is valuable economic resource in the world. Even most of the leading people, so number 1 rank, number 4 rank, number 5 rank people in the world, so the richest people in the world, they are having the asset of information, nothing else. Therefore, information is one of the most valuable economic resource. So the process of software, or the purpose of software, is to work with information. It needs a careful engineering process, and that's why SDLC is there. That's why the system development life cycle is there, and we learned about that in the last week. And today we will discuss further related to these things. And so what is the very first thing? So it is not mentioned here. What is the very first thing to do? So before identifying the requirement, yes?
Identify the problem.
Yes, identifying the problem. That is very important. Why? Because so if you don't know the problem, so how you can identify the requirements? That's my question. For example, so why you are coming to this class? Because you have a problem. The problem is facing the exam and get very good results. To address that, the problem is you don't have knowledge. So you don't have enough knowledge. You think that you don't have enough knowledge to answer the paper. That is the problem. The requirement is finding a good class. So then why you find in a good class? Because to answer the problem of knowledge, to get experience, to learn the subject, you need a lecturer. So that's why you are finding the requirement is lecturer and good class. But the problem is knowledge gap. To address the knowledge gap problem, you find a better class and a lecturer. So likewise, in any case, you need the problem definition, identifying the problem. That is compulsory. And anyway, it's not listed in the SDLs in your book. That is okay. That's totally okay, because so it mentioned all the main steps. But before we begin, we should know the problem. That is something prior to the SDLC. Okay, so as it mentioned, so this is iterable, or this is iterative. Why? Because after fixing the system, after implementing the system, there can be new problems, new requirements will be there to satisfy or answer that problem. For an example, develop a food path, but after developing, you might need a better infrastructure, better road. So the new problem is a wider road and new requirements. So new problem is comfort or travel in comfort. So you need, that is the problem. The requirement is wider road. So then more comfortability of the road. So maybe you need carpet road. So likewise, the requirement will change based on the problem. And anyway, so identification of the requirements. So that can be done in various methods. One is direct observation. You can go to the site, visit the site, and see what's really happening. Okay, let's discuss this with an example, right? Let's discuss this with an example. Assume that you are given a task to develop. You are given a task to develop a system or software to your school. So principal is asking you a school management system to enter student details and teacher details. The problem that he's having currently, assume that the problem that he's having currently is he has to look after a lot of files, which is a big hassle, big issue, because you have to secure the files. It is not easy to secure the manual files because these insects, rats and all might damage these files. The security problems are there, and it is inefficient to search that file and update the file. Sometimes some files are missing, but it is very difficult to find that file. Likewise, he is having a lot of problems. So you have to discuss with him and find out his problems. Okay, so let's write that as an example. Right. Phases, so write down the heading, phases of SDLC. Phases of SDLC. Phases of SDLC. Oh, that is not English. Sorry. Phases of SDLC. So let's try it according to the book requirement. That is, first one is requirement analysis. Analysis. The first one is requirement analysis. So L1 is missing. In this phase, a system analyst will identify the critical functional and non-functional requirements of the system. Functional and non-functional requirements of the system. Assume that you are given a task to create a school management system to feed data of students and teachers. School management system to feed data, SCHOOL, school management system to feed data of students and teachers. You have to play the role of system analyst. Easiest way to find out the requirements is visit the school and discuss with various stakeholders like principal, teachers, and students. So principals, teachers, administration, and students. So then one thing is you can visit the school, discuss with the stakeholders. Stakeholders means interested parties. Stakeholders means interested parties. Who will use or who will benefit from this system? Who will use and who will benefit through this system? Those people are called stakeholders. So you have to go visit and discuss with them. Okay, in addition to that, to gather details formally, you can give them a questionnaire and analyze the answers. You can give a question paper like thing. So what are the problems that you are facing with the current system? So examples, problems in current manual system. Time taken to do certain tasks. Expected reports. Those you can ask. Those you can ask formally through a questionnaire, question paper. It's not like exam paper. You give a set of questions and ask whether you are happy. The time taken to give this report. Is it 1 week, 1 day, or any time? So likewise. So let's say, so principal has asked teachers Let's think that principal has asked teachers, I need the best 100 students in the school, or I need the best 50 students in the school. Can you suggest? Okay, to get such report, how long it takes? That can be a question there. Or you can ask whether all details are completely there or some are missing. So likewise, you can ask questions. So you can discuss, you can ask questions. You can also monitor, observe, or also read and refer existing documents. In the manual system. You can also refer to the existing documents in the manual system. That is also a way of finding out information. Stay in the paper, so stay in the place and directly observe the environment. Stay in the place and directly observe the environment. When requirements are not clear, it is possible to develop a model or a prototype and make it clear to both developers, both the analysts and users. So these are the possibilities of analyzing the system. These are the possibilities. Please complete the note, then I'll explain one by one. If you are done, please let me know, then I can proceed. Requirement analysis. So you are asked to develop a system to your school and you go. So basically, this is the pace you find out what is really expected by the stakeholders or the interested parties. You go and observe. So that those are the things listed here. You can go and observe. One thing that you can do is you can go and observe. The second thing that you can do is you can conduct interviews. Second is you can conduct interviews. The third thing, questionnaire. Interview means discussions. Questionnaire means you can present a formal paper, formal set of questions and ask whether so they are agree or disagree or they have any comments. The questionnaires should not be like open-ended. So the best questionnaire should have like the choices as well as the open-ended too, right? So this is how the sample questionnaire for online learning, let's say online learning sample questionnaire. So distance learning things. So these kind of questions, so questionnaire can be given to you. So if we are developing a question, so if you are developing an online learning platform, we can give this kind of questionnaire to you here. How you feel the overall about the distance education. So it has some choices. Do you have access to a device learning online? It has some choices. What are the devices? What device you use for distance learning? Likewise here. So most of the things are selections. So even actually no open-ended, zero open-ended questions. But in some cases you can ask some open-ended also, because when you have these, it is really easy to understand the requirement. But when you give open-ended, when you ask user to write down it, so there might be a lot of issues. So better limit it to these kind of MCQs. So that is how you develop a questionnaire. Okay, now you know how to get these reports, how to get identify this. And document sample collection means you can refer to the previous things. කලින් පාවිච්චි කරපු files වගේම තියෙන්න පුළුවන්, registers, attendance report, progress reports. So those things you can refer and get information about the system. And prototyping is a very important thing, is prototyping. So have you seen the prototypes of, so these are the basic. So basically prototyping is used in many locations. So here prototype building. So when you want to build some large construction, you do a prototype. Because so you know that port city. So this is one thing. So this is similar to port city, a prototype or 3D model. Or it can be like this kind of physical model using Regiform also you can. So I think so this is we have done in our exhibition. You also, I think you have also done this kind of things. We have done a DNA prototype in our school exhibition, science exhibition. We have just done DNA prototype like this, or like this. So prototype means not, so DNA you can't see it, no? But prototype is just to understand what's really going on. So by referring to the prototype, you can say, right, this is okay. This is what I expected. So not only in DNA prototype, so you have prototype can be used in vehicles, car prototype. Prototype is a model, it's a suggestion. So you can say this is a prototype of car. The suggestion, suggested prototype. This is a prototype. Suggested version, a prototype car. A prototype car. Not a real one, it's a suggested one. So let's develop something like this. Okay, let's develop something like that is a prototype. Actually, it's not existing, but it is a model. So it can be 3D model or it can be computerized model also. Physically, පේන්න තියෙන එකක් වෙන්නත් පුළුවන්. නැත්නම් 3D එකක් වෙන්නත් පුළුවන්. So airplanes, basically plane, you do prototyping before develop. So normally prototyping is done. Why prototyping? Because then before developing the actual model, then people can comment about this. People can comment whether they like or they don't like, or whether there are issues. Likewise, they can prototype. By prototyping, you can show. So that is one of the main techniques used in identifying requirements, especially when requirements are not clear. Okay, then each of these is given like observation, process, meet the librarian and discuss, hand in a questionnaire and get her responses. Then reports and library cards, just read and see what is going on. So then prototyping, screenshots, records, samples can be given and ask whether you need this kind of thing. There are sketch to make a real one. So here, so it depends. So this is like a sketch, but in sometimes, in some occurrences, for an example, web prototype. So in web prototype means something like, okay, something so like this web prototype, basically you ask whether you need this one. There are prototyping tools also, right? Prototype කරන tools උත් තියෙනවා. app එහෙම prototype කරන්න පුළුවන්. Mobile phone apps. ඉතින් හදන්න කලින් මේ වගේ තමයි පේන්නේ කියලා හදන්න පුළුවන්. That prototype you can further develop. ඒ හදන prototype එක තව develop කරලා app එක කරන්නත් පුළුවන්. එතකොට අපි කියනවා evolutionary prototype කියලා. That means prototype can be further developed and create the real one. But airplanes and all, you can't do that. Airplanes වලදී prototype එක හදලා agree වෙලා prototype එක අයින් කරලා mobile phones වලත් එහෙම. For an example, iPhone 13, you can prototype. Before releasing that, you can prototype. Right? It shows the features which is going to come in. Possibilities of next version. But the prototype implementation, it depends. ඒකම develop කරන්නත් පුළුවන්. එහෙම නැත්නම් ඒක පැත්තකට දාලා ඇත්ත එක develop කරන්නත් පුළුවන්. දැන් phone වලදී එහෙම නම් කරන්නේ model එකක් sketch එකක් හදන්නේ sketch එක අයින් කරලා actual will be developed, but websites you can evolve the prototype, develop the prototype. Okay, so then the designing. So design is so here actually, so why designing is used to design the user interfaces, identifying the hardware requirement, user requirement, software requirement, database and data requirement, and the planning for the tests can be done in the designing phase. Okay, write down the second phase, that is system designing. System designing. In this phase, hardware requirements, software requirements, data and database requirements, testing requirements, and implementation requirements are planned using various standards and tools. In designing, maximum effort is taken to avoid ambiguous natural languages used in analysis and standardize the processes by using symbolic representations. Okay, it seems a bit complex. I'll explain this statement, right? I'll explain this statement. First you write this, then I'll explain. Right, so let me explain this. In designing, maximum effort is taken to avoid ambiguous natural language. So maybe, so here, the same thing. So when I write this, this is a note. So when you read this note, you will understand this in a different manner. So some will understand this very well and some will understand half away. Some will try to translate the note. එක එක විදියට නේ එක එක්කෙනා තේරුම් ගන්න එක එක විදියට. දැන් එක එක්කෙනාට කියවුවම තේරෙන වචන තේරුම තමයි ගන්න. Some will try to translate using dictionary. Some will try to answer or understand this using their common sense. Some will just translate. Likewise, different people will understand different way. That is the thing in the natural language. I think you have heard of story in so there, this is actually a historical story. I don't know whether the accuracy of this, but so when these foreigners, so these British people captured a person, so there was a message sent by our maybe so some actually leading person to the soldiers. So they have sent a message like this. And unfortunately, they kept some space. So unfortunately, they kept the mistakenly, I don't know, this is like this is a rumor. So they read like this. They read the message like this. So then, so the message says, Maranna, epa nidahas karana, don't release, kill him. So that is the message. But the intention of message, as I say, the intention of message is this. Don't kill, release him. But unfortunately, message was read like this. Kill, don't release. So that is the ambiguousness of language. Now you can see saving a life and maybe saving a life, or actually removing it, or saving a life or killing a person will depend on the language. So if you put dot here, so he will be released. But if you put dot here, he will be killed. So that is the thing. So if you are using natural language, that means the language that is actually understood by the human beings. So they will try to understand this in different way. But the symbolic representations like flowcharts. So examples, example tools, flowchart. So if you get this kind of symbol in a flowchart, if you see this kind of symbol, the meaning of particular symbol is input or output. So nothing else, input or output. So that is the standard symbol. So this represents input or output only. So it will simplify the problem. Example, flowchart will simplify input or output using this symbol. And it will simplify a process using this symbol. If you see this symbol, you know that is a process. This is a process. So likewise, symbolical things are used in system designing to minimize the complexity of natural language. Right? Minimize the complexity, and this will minimize the complexity of natural language. This will minimize the complexity of natural language. So that's why these tools are used. Example, flowcharts. Another example, you can say pseudocode and ER diagrams, entity, relationship diagrams in databases, and UML diagrams in programming. So likewise, there are different ways of applying system design. Actually, so they try to draw diagrams. That's why the picture here is given. They try to diagrammatically represent the things rather than writing it in the natural language. Writing a big note rather than writing a big note, it tries to represent things in diagrammatical way. As a flowchart, as a ER diagram, as a UML diagram. So that is system design. And the coding, that is next important thing. So please complete system designing part. Please complete system designing part and write down the third heading, coding. Right, coding is, or still you are writing, no? Okay, finish writing. So then write coding. Coding is one of the most important tasks in the implementation process. In this space, we will convert the design diagrams to workable set of instructions to handle the computer and get our work done. So that is what programming is. You instruct the computer and try to get the work done using the computer.